This is 2023, the year in which we can see to pictures of black holes. The year that allows us to find how many black holes are in our galaxy. The year in which we can determine how many black holes are formed within a second. But have you ever wondered how astronomers were able to discover the first black hole? You might not, right? Buckle up. This video will show you how astronomers were able to discover the first black hole. First clues about black hole came from an 18th century philosopher named John Michell. Michell tried to describe some kind of a dark star, which we can't see the light it emits. He concluded his idea as this: when the escape velocity at the surface of a star was equal to or greater than light speed, the generated light would be gravitationally trapped, so that the star would not be visible to a distant astronomer. And he also concluded that, in order to see that star, it should has a luminous twin circling round, which means that he is talking about a black hole with an accretion disk. 2 centuries after John Michell's prediction, Albert Einstein came into the game by discovering the theory of general relativity. Einstein's theory of general relativity proves that there can be objects in space which are gravitationally strong that even light can't escape.
It followed from the special theory of relativity that mass and energy are but different manifestations of the same thing. A somewhat unfamiliar conception for the average mind.
Fast forward to 1939. Oppenheimer and his colleagues published some papers. First, Oppenheimer and Volkov showed that neutron stars should exist. In the second paper entitled On Continued Gravitational Contraction, Oppenheimer and his co-author Hartland Snyder showed that a sufficiently massive star, when it exhausts its nuclear fuel, will necessarily contract forever and forming what we now know as a black hole. But as usual, astronomers dismissed these pioneering works as nothing more than an amusing trip to Fantasyland. Even Albert Einstein denied several times that black holes could form.
You know how much I sacrificed?
Well, as some few years passed by, an astonishing discovery was made. It was the first discovery of pulsar. Jocelyn Bell Burnell, on the 28th of November 1967, discovered the first radio pulsar. And then it was soon realized that neutron stars are the logical explanation of pulsars. So, if one of these fantasy lands can exist, why not the other? By this huge discovery, astrophysicists began doing theoretical calculations about black holes. By doing some calculations, scientists were finally able to predict the existence of a black hole. They proved that after the star went a supernova explosion, which means after burning it all fuel and exploded, if the remaining dead star has a mass more than 3 solar masses, it is a black hole. In other words, the mass of our sun multiplied by 3. The mass of our sun multiplied by 3 gives us a black hole. 1964. A sounding rocket launched from White Sands Missile Range in New Mexico. These instruments swept across the sky as the rockets rotated, producing a map of closely spaced scans. As a result of these surveys, 8 new sources of cosmic X-rays were discovered, including a very strong X-ray coming from the constellation Cygnus. For the further studies of these X-rays, Wuru, which was an X-ray detecting satellite, was launched in 1970. This satellite used to orbit around the Earth and found more than 300 new X-rays. The observations from Wuru shows that the strong X-ray from the Cygnus constellation, which is also known as the Cygnus X1, was changing dramatically. It is always changing. The bottom graph is belong to the X-ray source from Cygnus. And you can see how it is different from the other two. As you can see, this X-ray source has high top peaks and low bottoms. This proves that the X-ray coming from this source is changing dramatically. So the scientists began to focus their attention on this one specific X-ray source. Astronomers began to pinpoint this X-ray source by using an
iPhone camera.
I'm just kidding. So, by using the giant 140-foot radio telescope, at the National Observatory they began to pinpoint the source, and then they found a star, which they named as HDE 226,868, which is a blue supergiant. But the problem is that these kinds of stars do not emit this kind of strong X-ray source. So Cygnus X1 should be closely to this star, but not this star. During the spring and the summer of 1972, observations of HDE 2226868 revealed that it is in a binary system, which means HDE 2226868 is orbiting with a companion star, and that companion star is nowhere to be found. So it is invisible, which means it is in fact Cygnus X1. Some more data, the astronomers found that the star HDE 2226868 is emitting matter in the form of stellar wind, which means the gravitational field of Cygnus X1 is attracting the matter of the star HDE 2226868. Since Cygnus X1 is invisible, the matter it attracts should make an orbit around it as a huge disk. When this matter rapidly rotates, the friction develops, and this causes the matter to turn to gas and spiral closer and closer to the hole. So the temperature increases so much that when the matter gets closer and closer to the hole, temperature rises to millions of degrees. At this tremendous amount of temperature, the disk becomes transparent and radiation pours out, and strong X-rays are emitted to the space within milliseconds. So finally, this proves how the strong X-rays are produced by Cygnus X1. So finally, astronomers were able to found what Cygnus X1 does look like. To come to this conclusion, they used the following method. There is a method in astronomy that can measure the mass of the objects if they are in binary orbit using Kepler's laws. By using the following method, they found that the mass of Cygnus X1 is more than 3 solar masses. If you can go a few more minutes back in this video, you can hear that I told you that the scientists found that when a dead star is more than 3 solar masses, it is a black hole. So finally, by using this method, scientists concluded that the Cygnus X1 is indeed a black hole.